Hi, this is Danny Tang. Today I'm going to be talking about my project for the Digital Signal Processing 2 class. And my project is comparing two algorithms for linear inverse problems, and these two are the FISTA and the twist algorithms, which are improvements on the original ISTA method. So linear inverse problems uh, such as image denoising, can be treated as convex optimization problems. And so the way to solve linear inverse problems is to minimize the data error. And because this is a really complex process, we want to use something called iterative shrinkage thresholding algorithm, um, which was developed using EM and then later MM approaches. And because the ISTA method is pretty slow and converges slowly, um, people have made improvements to the algorithms. So two of them are the FISTA, the fast. It's called FISTA because it's called the fast iterative shrinkage thresholding algorithm, and the twist, which are the two-step iterative algorithm. So there are two different papers discussing these two algorithms, and both claim that they're faster than the original ISTA method. So they both have different equations, and these equations are then implemented in MATLAB, so we can see if they truly are faster, or if they're, or maybe if they're better at denoising the images as well. But the main thing is to see if the convergence is faster than the original IST algorithm. So for FISTA, there are there are three steps. So instead of performing the shrinkage operator on x of k, now you perform it on y of k, and then you update t of k and y of k. And y of k is a linear combination of the two previous x of k points. So the last two, the 4.2 equation and 4.3 equation, are just updating the new estimates instead of just doing it in one shrinkage operator equation, which is what the IST algorithm does. And in the in the twist algorithm, there are also two equations, so they split it into two because the authors were looking at the iterative reweighted shrinkage algorithm, which had two steps, and they were inspired by this because the algorithm converges much faster. So they came up with two new equations. So they have x of 1 is equal to the gamma of x0. So x0 is some initial x, and the second step is the x of k plus 1. Well, in this case it's t plus 1, but so this depends on two previous x of k values. So x of k minus 1 and x of k minus 2. And so the psi operator here is the denoising operator. By default, it's the soft thresholding algorithm according to the authors, but you can specify what kind of operator it is. So, and then the alpha and beta values, they're calculated depending on what lambda values you put in. So in implementing these algorithms in MATLAB, they're pretty straightforward. For FISTA, basically the three steps are written in this for loop here: x of k, t of k, y of k, and then you update the values every time you iterate through them. Um, yeah, so that's pretty straightforward. And then for the twist algorithm, the the most important part is to figure out the twist parameters, which depend on the lambda value. So lam1 is input by the user into the function, and so you can have different values for depending on your problem. So for severely ill conditioned problems, you want 1 times 10 to negative 4, and then 1 times 10 to negative 2 for mildly ill conditioned problems. And they set 0.04 as the default. So then, as you can see, the alpha and beta values are calculated from the lambda values. And then the actual twist algorithm, the 2 steps, the first step is just an equation, and then the second step is in the loop. So you want to loop through the second step, which uses a x of k minus 1 and x of k minus 2 values, and then you update them in the loop. So in testing the experimental results, in FISTA they found that, in TWIST they found that the objective function converged rapidly and at fewer iterations as compared to the IST algorithms. But they didn't say that it was better at deblurring the images, it was just faster. And so in these graphs, you can see that it's much faster. The black solid line is the objective function evolution. So you see that the dotted line and the grayed outline are the IST algorithms. So this one converges faster and at fewer iterations. And then the FISTA experimental results show that, well, the authors claim that they're not only better at denoising images than ISTA, it's also faster. So they also claim that FISTA is better than monotonic twist. So they think that FISTA is the superior method here, but we want to take note that that's not necessarily true. The authors of the twist algorithms, the authors of the twist algorithms looked at all the different algorithms. They looked at 4 different ones. In this project, we only looked at 2 of them, twist and FISTA, and their graphs show that the objective function evolution for twist is actually better than FISTA. So I guess it depends on your linear inverse problem. So we can't say one is much better than the other, but they're both definitely better than the original ISTA method.